Algebra 2 class. In today's class, we are going to go through lesson 7.16, which is all about the quadratic formula. Now, there are a couple warm-up problems in this that we would have looked at normally in class, but to try to keep this video as short as possible, I'm going to jump right into the bulk of the lesson today, which is about how do we actually go about using this thing called the quadratic formula. So first we should address, well, what is the quadratic formula? So far in this unit, we have talked a lot about how do you solve quadratic equations. And we've looked at a couple main ways to do that. One of them has been sometimes we can just use algebraic reasoning and isolate x. Another that we worked a lot on has been, what if I can rewrite a quadratic equation in standard form and use that to solve the equation for x? And I guess technically we talked about a third one as well, which is graphing. If I can graph a quadratic, then I can sometimes solve the equation that way. Well, some of those work really well in certain situations, but the quadratic formula is a great tool for solving any quadratic equation, and I mean any. This will work every single time. So I just put the quadratic formula itself in a box, and you will notice there's a lot of letters flying around here, A's, B's, and C's. Well, A, B, and C are going to come from the problem itself. And it is very important when we are using the quadratic formula that this is always our starting point. We must make our equation look like ax squared plus bx plus c equals 0. To give you an example, they give you one right here. Here's a problem that looks just like that. And in this case, it is an invisible 1, x squared, minus 8x plus 15 equals 0. So they tell us that a equals 1, because it's the number in front of the x squared. B equals negative 8, because it's the number in front of the x. And c equals 15, because it is the number that is all by itself. Now they go through and kind of run through an example there, which you are welcome to look at, but I'm going to jump ahead and we're going to look at some examples of our own. I am going to bring the quadratic formula down here with us so we can refer to it, but we're going to run through this problem right here. So in this first one, first of all, the thing we should check, is it set up nicely for us? Well, it is. This is already in ax squared plus bx plus c equals 0 format. And we can go ahead and find a, b, and c. So a in this problem is again an invisible 1. B in this problem is the 4 that's in front of the x. And c is the number that's by itself, which is the negative 5. So now what our job becomes is to fill in that quadratic formula. So we're going to go ahead and fill in the blanks. It starts off with negative b. And in this case, b is 4. You're going to notice I use a lot of parentheses in these problems, and I'm doing that on purpose because it helps us keep track of negative signs a lot better than if we just start throwing numbers in there without any parentheses. So it starts off with negative b, which is negative 4, plus or minus. Now this plus or minus symbol means that eventually we're going to get two answers here. When we have simplified this down far enough, we will do the plus version and get an answer. And then we will do the minus version and get an answer. We're not there quite yet. Then we have the big square root. And under that big square root, we again have b squared, which is 4 squared, minus 4 times a is 1, times c is negative 5. This is all divided by 2 times a, and again, a is 1. So we've done kind of what's usually actually the hard part of this problem is figuring out what a, b, and c are correctly, and then plugging them in without missing any negatives or putting any pieces in the wrong spots. The rest of this problem is just arithmetic. It is calculating out what does this mess actually simplify down to. Now, some of you will be very comfortable doing this process, and you will do this quite quickly in a couple steps. I am going to do it out step by step here to show you every single piece done out carefully. So the first part, -4 is just -4. That's it. Plus or minus, big square root is still there. Underneath that square root, we have 4 squared. Well, that's 4 times 4, which is 16. And then we have -4 times 1 times -5. -4 times 1 times -5 is positive 20. And then this is all still divided by 2 times 1, which is 2. So that's my first step, is I simplify a bunch of little pieces all around the formula. Then I look under the square root and I start to attack this more. So x equals -4 plus or minus the square root of 16 plus 20 is 36. And then that fraction's still there, divided by 2. Well, in this problem, I can actually do the square root of 36. The square root of 36 is 6. If you're ever unsure about what that answer might be, put it in a calculator. OneNote actually has a calculator built in that will do that. If you type SQRT parentheses 36, you can have OneNote do it. Square root of 36 is 6. But let's keep going. Still a fraction divided by 2. Once we are here, we can now split this up into 2 separate problems, because now we have simplified it enough that it's time to attack that plus or minus. So the plus version, -4 plus 6 divided by 2. Well, -4 plus 6 is 2, divided by 2 is 1. So our first answer is that x equals 1. I should probably keep that. This is x equals. Our second answer is going to come from the minus version. So x equals -4 minus 6 over 2. Well, -4 minus 6 is -10. Divided by 2 is -5. And that's our second answer. So again, we got 2 answers. They already told us what the answers were, just so we could double check as we went along, and we matched up with what they said. We're going to skip over number 2, but it's a good one to go back to if you want some more practice. We're going to look at number 3. And again, I'm going to bring the formula down with us. Number 3 is again set up nicely. ax squared plus bx plus c equals 0. So we can jump right in and say, hey, a is the invisible 1, b is positive 10, and c is positive 18. They're all right there for us. And then we can go and start to fill in the blanks. So x equals -b, and this time is -10, plus or minus the square root of 10 squared, that's b squared, minus 4 times 1 times 18. That is 4 times a times c. All divided by 2 times a, which is 2 times 1. So then we filled in all the pieces very carefully, using our parentheses well. And from here we go to simplify. So x equals -10 plus or minus the square root of 10 squared is 100. -4 times 1 times 18 is -72. And then on the bottom, 2 times 1 is 2. From here, -10 is still just -10, plus or minus. 100 minus 72 is 28. So we have the square root of 28 here, divided by 2. You might have noticed right at the beginning that their answer looks a little funny. It's not a nice number. It's -5 plus or minus the square root of 28 over 2. Well, this is where that is coming from. The square root of 28, if you're not sure, is not a whole number. It does not come out nicely. It is 5 point blah, 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 blah. And that decimal goes on and on forever. So the square root of 28, I can't write the exact answer if I use a decimal. And because this is just a pure mathematics problem, I want to write an exact answer. And the only way to do that is to leave it with the square root still there, which means this answer right here is perfectly acceptable. We're going to leave it with the square root in it. And you might have noticed that they have -5 Well, that's just negative 10 divided by 2. That's where that negative 5 is coming from. So that is where that part comes from. Now to talk a little bit more about this idea, we have some possibilities here. The first possibility, which we already saw, if you do the square root, now let me type that differently. If the square root gives a whole number, use it. Use the square root, just do it. Use that number that you get out. But like we saw here, if the square root gives a crazy decimal, keep the square root. Do not use the crazy decimal. There is one exception to this rule, and I want you to imagine that this was a word problem for a second. Let's say this problem said something like, how long will it take for the object to hit the ground? I don't want you to tell me that the object takes negative 10 plus or minus the square root of 28 over 2 seconds to hit the ground. I have no idea what that means. So what I want you to tell me in the word problems is to round the crazy decimal. So in word problems, round the crazy decimal and use it. Now that doesn't mean round to a whole number. It just means round it, maybe to like 2 decimal places and use that. But decimals are fine in word problems because we want a number that we can actually think about. I don't want negative 10 plus or minus the square root of 28 over 2. I want to look at one last quadratic formula problem here, which is number 5. And again, I'm going to go ahead, bring that quadratic formula down with us, and we'll get started here. This is again written in the nice format for us. ax squared plus bx plus c equals 0. So in this case, I can jump right in. A equals 9 this time, b equals negative 6, and c equals 1. We're getting those because the 9 is in front of the x squared, the negative 6 is in front of the x, and the c is in front, and the 1 is always the number that's by itself. So we go ahead and fill in the quadratic formula. X equals negative b is negative 6. So you can kind of see here where the parentheses are helpful. Now I can see both those minus signs clearly. Plus or minus big square root b squared. So that's negative 6 squared. Again, these parentheses right here are very important. If you do not have those parentheses, you will not get the right answer when you type this into a calculator. Negative 6 squared, you need the parentheses around the negative 6. Minus 4 times a is 9 times c is 1. All divided by 2 times a, which is 2 times 9. Again, first step, I'm just filling in all the blanks. That's all I'm doing. Then we go ahead and start simplifying. Negative 6. Double negative is back to being a positive. So that's 6 plus or minus the square root. Negative 6 squared means negative 6 times negative 6, which is positive 36. Minus 4 times 9 times 1, well, that's minus 36. All divided by 2 times 9, which is 18. Now here's the second thing that's going to happen. It's a little different. 36 minus 36 is 0. So this comes out to 6 plus or minus the square root of 0 all over 18. The square root of 0 is just 0. So x equals 6 over 18. Sorry, let me back up one step. Kind of skipped ahead there. X equals 6 plus or minus 0 over 18. Well, adding 0 to 6 and subtracting 0 from 6, that gives the same answer both times. You just get that x equals 6 over 18, which we can simplify. That's 1/3. So our answer here, x equals 1/3. We only ended up with one answer on this one. That's okay. We know that some quadratic equations only have one solution. Now it's usually around this time that I get a question that is, where is this 4 coming from? There's no 4 in the A, B, or C. Well, that 4 is always there. It is built into the quadratic formula. So that is why that 4 is in this problem. That's why the 4 was in the last problem. It is built into the formula itself. So just don't worry about that 4. It's always going to be there, right in that same spot. Now, before I set you free to work on your homework, there's one more type problem I want to check out. Because I said it was really important that our starting point was always ax squared plus bx plus c. Right? That always had to be our starting point. Ax squared plus bx plus c equals 0. Well, it turns out that not all quadratics start that way. If you look, for example, at something like c, that is not in order, so you have to be careful when you do that. You have to find the a value, which is always the number that is in front of the x squared. So that's 5 in this case. You have to think about it that way. D, E, and F are even a little bit trickier because these 3 are not equal to 0 yet. I have to make this into a 0. I have to make this 1/3 into a 0. Well, how do I do that? I subtract 1/3 from both sides. Once we do that, we'll get 4/5 x squared plus 3x minus 1/3 equals 0. And then we're looking more like a normal quadratic. A equals 4/5, B equals 3, and C equals -1/3. E and F are similar. You need to make sure that you get them to look like ax squared plus bx plus c. E has its own twist, but that's okay. I'll leave that up to you to try out. Just keep in mind, here's your hint. Sometimes B or C is allowed to equal 0. So that is the hint I will give you on problem E as you go through this. Now, last thing to point out, problems 1 and 5 only ask you to find A, B, and C, not solve. Problem 2 on the last page here, this actually asks you to solve. So make sure you are finding the final answers here by running that through the quadratic formula. Good luck, and if you have any questions, I will be back next class to answer them.